So let's give you some template for the limiting reagent. So any of the limiting reagent, you can follow the same method. The kind of solving template. You can follow. So you always start with the balance equation. So you're given that if the balance equation, the chemical equation, if you're given that, let's write it down. You're given the 2H2S which is a gas, reacting with 3 of the oxygen, O2 gas, producing the 2SO2 gas and the 2H2O gas as well. So now, state inside of that question would not be marked or would not be a set sometimes, but I still recommend you write all the states here. You never know. Okay, and then what you do is you gotta find the N of the reactants. Given. Now, we only learned a few methods, like a couple of methods to find the N. From next week, we're going to learn a new method to find the number of moles. That's using the concentration and volume. Another one coming in the week after, like in 2 weeks later, they're using the gas laws, but this is the universal. You can find the N, but this time you're given. So let's for question A here, you're given the 3 moles. Let's write it like this way here. N of the H2S given is given at 3 mole. N of the O2 given, that's a 4 mole, that's given. So you can use the any of the methods, whether you use the N equals to mass over molar mass, or that equals to N over Avogadro's number that we learned. Later on, you got to learn about C times V, concentration times the volume, or you can learn about PV equals to nRT, the P V over RT, many of those values too, or even that N times molar volumes too. Don't worry about too much about from here. We're up to this stage, just up to stage that, and this is the things that are getting more complicated because you have given different like solutions, gases, and you need to figure out what formulas you have to use. But not for now. Okay, after that, you're using that to choose one of the reactant as a standard, and then using the reaction ratio to determine the other reactant required. So for example, if I chose any of those, you can choose anything in here. I choose that and O2 here. Okay, you can do anything basically. I chose that for the number of O2 given. For the full or you can write it as this: to completely react the N of the O2 given, the number of mole of the H2S required is calculated by using the ratio. So you're given the N of the H2S to N of the O2. That's given as, you're following to the reaction ratio that we have a 2 to 3, 2 to 3. Okay, that means solving that, you're going to get 2 of the N of O2 is given as 3 of the N of the H2S like this. Okay, now what we want to find is we want to get the H2S. So therefore, giving you that N of the H2S, N of the H2S will be the same as moving that 2 on 3 of the N of O2. Therefore, just writing in this space here, number mole N of the O2, number mole of the H2S required, we need, is same as 2 on 3 times that, and O2 you're given, that's a 4. So giving you what? 8 on 3 mole is the amount we need to have. 8 on 3 is approximately 2 point something. Now compare the two. After that, compare the required value, or required, I should say, amount, is the better word, required amount to the given amount. So let's have a think about this case here. If you have n of the required and n of the given, if we have a greater than n of required there, okay. If you have a more than, if you have a less than what we required, you can interpret that you have a less than, you're given given less than what we need, what it is required. That means your n given, the n given is the limiting reagent. In other words, if you have something like this, if you have n of the required this time, it's less than n of the given, then you're given more than what we need. More than needs. Basically, just write it in this needs. Then that means n of the given is in excess. Means that other one will be your limiting reagent. So using that, you're given the H2S, n of the H2S given, required, that is 8 on 3 mole again. Compare that to n of the H2S given, you're given amount of the 3 moles. Comparing these two, which is bigger, we have smaller. So in the case of this, you have less than what you need. You're given more than excuse me. You're given more than what you need. This means what? The H2S is in excess. You get some left over the H2S. Therefore, that means your O2 is the limiting reagent. Now, rule number 5, if you want to find the excess, n in excess, always find from n of the total or the given minus n of the reacted, where n reacting is following the n of the limiting reagent. So what's the limiting reagent we have? We have O2, that's the limiting reagent here. That's 4 moles. So we're going to follow that ratio. So amount of the, for example, amount of the n of the H2S reacting is then following the reaction ratio again. That'll be 2 on 3 of the n of O2 you're given. That's what? That's 8 on 3. As NO2 was given as that. The 4 moles here again too. Therefore, in excess, n of the H2S in excess would it be n of the H2S that's given minus n of the H2S that's in the reacting. That is H2S given, you're given a 3 minus 8 on 3. So that's giving you 1 on 3 mole, or approximately 0.333. Let's write in some decimal points. So that's giving you 0.333 mole in 3 sig figs. This is the full working out and the templates you can use till you finish your HSC basically. Because you get all that limiting reagent and excess amount, and you get lots of those questions more than you imagine. And the values, as we can deal with like some of the more complicated reaction ratio here, the coefficient can be a little more complicated. So I strongly recommend you using that mathematical method to find it out amount of mole. So yes, you may use your in your head, you can quickly calculate how much of the N ratio that, but just recommend it. You can just write it down on the top of the page. Okay, you don't have to show in the working out. You're just gonna write on the top of the page, get to figure out the number of mole ratios easily. Okay, this is how we can get which will be the leftover after reacting. So we just need to find how much is not how much is left over for this question. You just need to figure out which will be in excess. So same for the B, C, and D. You can use the same method. I can share that. You can just change the values in. You can just change the values in, and then you can figure out which will be your limiting reagent, therefore which will be in excess to. Okay, try for question 1 and 2 now. Try to use a template as you go. Like, just practice that and build some muscle memory for these type of questions again. This is all about actually the muscle memory. So you realize that at the end, your hands is writing down all the working out without much thing like going on to the limiting reagents.